Hey guys, so we have this question and we have to solve the deflection at point D. Okay, so to determine the deflection at point D, first we need to determine propped, the magnitude of propped reaction. Okay, so if we draw the free body diagram, it will be like this. This P, this is R, and this is P. So at this point, delta C will be 0. So we can use this condition for determining the value of propped reaction. So if we use the general formula of deflection of cantilever beam, so it will be PL cube upon 3EI and theta will be PL square upon 2EI. This will be the deflection and this will be the theta. Okay guys, so first we determine the deflection at point C. So the deflection at point C comprises of uh, these load, the load P here, the load P here, and the reaction. So if I want to write the expression for deflection, I will take like delta C is equals to P L cube upon 3I plus. So because of this load, suppose like this, there will be a deflection here, and beyond this point the bar will not deflect anymore because there is no bending moment in this zone. So the deflection will be like this and a straight line. So the rotation at this point and this point will be equal, and the extra deflection will be theta L theta multiplied by L. Okay, so we will use this formulation in the above formula. So PL cube by this load, PL cube upon 3I multiplied by PL square upon 2EI into L. Okay, then if I take the deflection due to this point D, so it will be like this. There is a P here, point D, and we will need to determine at this point. So the deflection will be like this. Okay, so it will comprises of what? This and this, the P and PL. The moment will transfer at this point C from point D. Okay, so the deflection will be due to the point load plus due to the moment. Okay, so for this the expression will be plus P 2L cube upon 3EI plus PA, and if there is a moment applied at this point, then delta will be ml square upon 2EI plus, sorry, and theta will be ml upon EI. Okay, so PA, which is the moment, and L square will be 2L square. So here we have not PA, it would be PL 12 square upon 2EI. Okay, so these two deflections will be downward, and due to RC the deflection will be upward. So total deflection at point C will be 0, and we have R is equals to now we have the propped reaction, which is 2.06p. Okay, and if I draw the free body diagram again, like P is here and there's R 2.06p and P also here. This is L, this is L, this is L. Okay, and this is point D. Now if I write the expression for deflection at D, it will be like for this term PL cube by 3EI plus PL square upon 2EI multiplied by the distance from B to D, which is 2L. Okay, and if we talk about the propped reaction, it will be 2.06p 2L cube divided by 3EI. And if I talk about this, it will be what? P times 2 P times 3L cube by 3I only. So the final deflection at point D will be PL cube upon 3I plus PL cube upon EI minus 5.5 PL cube upon EI plus 9 PL cube upon EI, and the final deflection at D will be 1.84 PL cube upon EI in the downward direction. So this is how we can calculate the deflection at point D. And if we want to determine the rotation at point D, that we can also determine, or rotation at point D, the expression will be theta D is equals to rotation due to this point load. This will be PL square upon 2EI, and due to the propped reaction 2.06p 2L square upon 2EI, and for this load it will be P 3L square upon 2EI, and theta D will be 0.88 PL square upon PI.